Hi guys. So in a previous video, I gave you this circuit which consists of a bunch of capacitors, right? And there is a battery here. And the question was, what is the effective capacitance between these 2 points, right? Now just to recollect, so we said, let's say if I connect those 2 points to a battery, right? The way to solve this is think about mentally as the battery is sending some charge to both the sides. So plus Q minus Q, right? Number one. Number two, for each capacitor, the 2 plates will have the same charge but in opposite signs. So if this is minus Q, this becomes plus Q, this is plus Q, this becomes minus Q, okay. Now third is the charge is conserved, right. So which means before I connected this, let's say from here to here to here, this whole T, right, this whole thing was electrically neutral, which means if minus Q has come here, which means plus Q has to go to both the other plates. So here, let's say this is Q1, this is going to be Q minus Q1. Same logic. Now, if this is Q1, the other side has to be negative of that, and same here, right? So now we have all the charges assigned to each of the plates of each capacitor. Next is voltage. Now the potential difference here is V. So take one side as 0, and the other side, just take this as any point as 0 here. So this becomes V because there's a battery here. And now here, let's say the potential difference across this is V1, across this is V2, right? So if this is V, here it's going down, so this is going to be V minus V1. Here this is going up, so it's going to be 0 plus V2. This is V2, this is V minus V1. Now the potential difference across this is going to be this V minus V1 minus V2, and these two capacitors, they'll have the same potential difference, right? Because both of them are effectively in parallel. Okay, so now what did we say? We said if you want to find the effective capacitance, right, for each of the capacitors, write the equation, right? We will write the equation Q equals CV, right? And then we will eliminate all the Q1, Q2, Q3 and V1, V2, V3, etc. Right? So let's do that. So now let's start with this one. So here, by the way, the capacitors, let's give them names, right? So this is my C1, this is my C2, this is my C3, and this is my C4. Okay. So now let's solve this, right? So what will this be? So this would be, so let's say this capacitor, right? So let's write the equation. So first one, here Q equals C1 V1, right? So we have Q equals C1 V1. That's my first equation. Second, here Q equals C2 V2. Q equals C2. Second equation. Third, right? Here this would be Q minus Q1, right? This is equal to C3 into potential difference. What is that? That is going to be V minus V1 minus V2, right? So the potential difference is going to be V minus V1 minus V2, right? So that would be C3 into V minus V1 minus V2, and this is going to be my third equation. The fourth one, it has the same potential difference, right? But the charge here is Q1, so it's going to be Q1 is equal to C4 into V minus V1 minus V2. Right? Now we want to get rid of all the Q1, Q2, Q3, V1, V2, V3 and so on. So how many of them are there? So we want to get rid of Q1, right? There is no other charge here. Q is what we want. We want ultimately an equation of this form, right? So Q we need, and similarly we want to get rid of V1 and V2, right? So there are 3 equations. So from each one of them, using this I can get rid of, let us say V1. Here I can eliminate V2. Here one of them I can eliminate Q1, right? So then I can eliminate all of them, and then I can get an equation of this form, and then Q upon V, right? That is going to be my total effective capacitance. So now let's start. Now this is all, rest of it is pure mathematics. Physics is over, okay? Rest is pure algebra. So let's eliminate now. So how can I eliminate V1? So V1 would be nothing but Q upon C1. So V1 is equal to Q upon C1, right? And by the same logic, right? Same logic, I can write that V2 is equal to Q upon C2, right? So these are two, so this V1, V2 I can get rid of, and now I need to get rid of Q1. So from these 2 equations, right, this is Q minus Q1, sorry, this is my Q1, my apologies, this is Q1, right? So now I can, if I add these 2, right, the LHS and RHS, this Q1 minus Q1 will cancel, so that does my job. So adding 3 and 4, so 3 plus 4, right, what does that do? That gives me Q minus Q1, right, plus Q1, right, Q minus Q1 plus Q1 is equal to C3, this factor is common, so it will be C3 plus C4, right, into V minus V1 minus V2, right? Now Q1 and Q1 cancel, my Q1 is taken care of, and now I can substitute the value of V1 and V1 and V2 here. So I'll get Q equals C3 plus C4, right, into V minus V1. What is V1? V1 is equal to Q upon C1 minus Q upon C1, right, minus Q upon C2, right. Now let us try to get an equation which would be where we can find Q upon V or V upon Q or whatever. Then from there I can get my capacitance. So how do I do that? So I will just take all the Q terms on this side. So I can write this as, this would be Q, right, plus, right. So this would be C3 plus C4. Okay, let me simplify this step by step. This would be C3 plus C4 into V, right, minus Q into C3 plus C4, right, into 1 upon C1 plus 1 upon C2, right. Can you see this? So this is C3 plus C4 into, this is minus Q1 into 1 upon C1 plus 1 upon C2. This is my, so this term is nothing but this into these two, right. Now I can take this to the left hand side, and then I think my job will be almost done, right. Let's do that. So this would become now Q into 1 plus C3 plus C4, right, into 1 upon C1, right, plus 1 upon C2, right, plus 1 upon C2, right, and this is going to be equal to C3 plus C4 into V, C3 plus C4, right, into V, right. Now if I look at V upon Q, right, I know that Q upon V is C, but let me see V upon Q, it will be 1 upon C. So I can write that V upon Q, right, this is going to be equal to V upon Q is going to be equal to 1 plus C3 plus C4, right, into this term, right, into 1 upon C1 plus 1 upon C2, right, and now this whole thing will come to the denominator here, right. So this will be this whole thing divided by C3 plus C4, right, and what do I find this is? This is going to be 1 upon C3 plus C4, right, plus here this is going to cancel, right. So the second term C3 and C4, this and this, they would cancel, so I'll get nothing but 1 upon C1 plus 1 upon C2, right. Now from here we can see that Q, what is V upon Q? V upon Q is going to be nothing but 1 upon C, right. So this is what? This is 1 upon equivalent capacitance, right. So V upon Q is going to be 1 upon equivalent capacitance, which is nothing but equal to 1 upon C3 plus C4 plus 1 upon C1 plus 1 upon C2, right. This is my answer. And what is the pattern we see here? The pattern we see here is that remember when we said when we have capacitors in series, right, then 1 upon C equivalent or total is going to be equal to 1 upon C1 plus 1 upon C2, etc., right. So here it looks like the total capacitance is as if we had C1, C2 and C3 plus C4 in series, right. And what does C3 plus C4 mean? Which means C3 and C4 are in parallel. So what we're saying is C3, C4 are in parallel and they together are in series with C1 and C2. And let us look at this. What do you find? Exactly the same thing. So here we have C1, C4 and C3 in parallel and then in series with C2, right. So C1, this combination, and C2, they are all in series and these two are in parallel, and that's exactly what we found, right. Now obviously we could have solved this problem without going through these steps, but just by using the series parallel combinations, but I wanted to illustrate this more general way of solving a circuit where you have capacitors, right. Now the same technique you can use for any circuit, where you have capacitors in different configurations. Thank you.